Good morning. So this is double integral in polar coordinates. Let's understand this geometrically. It is given that there are two curves AB having r equal to f1 theta and CD with r equal to f2 theta. So let's draw these curves first. So let this be your x-axis and let's draw these curves. The first one is AB. So I'm drawing this curve AB having r equal to f1 theta, and then the other curve as CD having r equal to f2 theta, right? And now these curves are bounded by the lines theta equal to theta 1 and theta equal to theta 2. So let's draw these two lines. These curves are bounded by the lines theta equal to theta 1. This is your theta equal to theta 1, and the other one is just taking this as like this. This is theta equal to theta 2, marking this angle as theta 1 and marking this angle as theta 2. This is theta 2, right? And then wedge of angular thickness delta theta. There is also a wedge having the angular distance delta theta. This is your wedge named as PQ. Let me name this wedge as PQ, and it is having the thickness delta theta, right? Okay, now if we integrate with respect to r, this means what? This means that we are integrating along this wedge PQ, right? Where when we integrate with respect to r, the integration is along PQ, which means r is varying and theta is constant for this. And when we integrate with respect to theta, which means this strip, there is a rotation of this strip from, okay, let's name these curves also as this is curve AB and this is curve CD. So there is when we integrate with respect to theta, this strip is rotated from AC to BD. There is a rotation of this strip PQ from AC to BD. From AC to BD, right? Okay, let's do an example. Evaluate this double integral from 0 to pi by 2, 0 to a cos theta, r square root of a square minus r square dr d theta. Now here first we will integrate with respect to r. The limits are in the form of theta, and when we integrate this with respect to r, we get the expression by putting the limits, we get the expression in theta. And because the last limits of this integral are from 0 to pi by 2, which are the limits for theta, and then we integrate with respect to theta and putting these limits, right? So let's solve this. So let's solve the inner integral first. This is r square root of a square minus r square. It is very easier to integrate this. First I'm solving this integral. Just putting this as a remark. So the integral is r square root of a square minus r square. What do you get? Just put a square minus r square equal to t. So a square minus r square, put this is equal to t. And then you will get minus 2r dr is equal to dt. Now here I am having r dr. I need minus 2r dr. So let me subtract minus 2. So let me multiply minus 2 and divide with minus 2. Okay. So this minus 2r dr, this becomes dt. And there I am having minus 1 by 2. And this is square root of t. Right. This is equal to minus 1 by 2. What is the integration for t power 1 by 2? This is t power 3 by 2 over 3 by 2. So this is equal to Just cancel these two. I get minus 1 over 3 t power 3 by 2. And putting back the value of t here, I get minus 1 by 3 a square minus r square the power 3 by 2. So I'm using this result here. Alright, so the integral of r square root of a square minus r square is minus 1 by 3 a square minus r square power 3 by 2. From 0 to a cos theta, and then this is d theta. So now putting here first a cos theta inside, putting the limits, we get this is equal to, the integral is from 0 to pi by 2, and taking minus 1 by 3 outside, this will become, this is a square minus a square cos square theta, which is a square into 1 minus cos square theta, which is sine square theta, right? And the power is 3 by 2. So this will be a cube sine cube theta, right? And then putting 0 over here, I get this a square the power 3 by 2, which is again a cube. So minus a cube d theta. And then this is equal to, please notice here, just splitting this, I'm having the integral from 0 to pi by 2 a cube sine cube theta. And I'm going to use a reduction formula here, which is very easier to use. This is a cube d theta. Okay, what is the reduction formula for that? Taking a cube as it is. Alright, sine cube theta. The power is 3. So subtracting the power with odd numbers in the numerator. So 3 minus 1. And then 3 minus 3, that will give you 0. So there is no need to write this. Over the power. Now in the denominator, subtract the power with even numbers. So this is 3 minus 2 and then 3 minus 4, not required. And because the power is odd, so there is no need to multiply with pi by 2. So stop here only. And then plus 1 over 3 a cube. Integration for 1 is theta. From 0 to pi by 2. So this is minus a cube over 3. And this is 3 minus 1, 2. This is 3. 3 minus 2 is 1. Plus 1 over 3 a cube. And it is pi by 2 minus 0. So this is negative. Taking this a cube over 3 common. So this will become 2 by 3. And this is minus pi by 2. And after more simplifying, you get a cube over 18. Taking the LCM, you get a cube over 18. 3 pi minus 4. Up to this is also okay, right? So this is how we solve the double integrals in polar coordinates. Thank you.